Hello, I'm Oleksii Kudryk. I'm PhD candidate of Vinnitsa National Technical University. The topic of work is knowledge base of intelligent information system for prediction of phase stability of solid solutions. Currently, compounds of rare earth elements with tetrahedral oxoanions like phosphates, vanadates, silicates, and arseniates are being intensively studied. This is due to their use in the manufacture of materials for phosphors, lasers, LEDs, displays, and tomographs, and for disposal of various radioactive wastes, including nuclear reactors and dismantled nuclear weapons, as the service life of aluminophosphate or borosilicate glass used for these purposes is only up to 30–40 years. The purpose of article is to develop a knowledge base for intelligent information system for prediction the phase stability of solid solutions. Knowledge base means a set of facts and interference rules that allow logical conclusion and purposeful processing of information. Expert system is a software tool that uses expert knowledge to provide a highly efficient solution to informational problems in a narrow subject area. The basis of expert system is the knowledge base about the subject area, which accumulates in the process of construction and operation of expert system. Accumulation and organization of knowledge is the most important property of all expert systems. So, before the system can work, it must be filled with data. Data for the system were taken from various scientific sources, both modern and fundamental, which were published in 1930 till 1970. The data set is very large, because for each lanthanide it's necessary to enter a number of parameters that are necessary for prediction. You must also enter parameters for each type of system. Let's consider the model of the production type knowledge base for prediction of the phase stability of solid solutions. Let's present the model being developed as knowledge base, which consists of relations, production rules, predicates, functions, and operators. The following are the formal relationships that allow us to consider the informational component of the intelligent information system of phase stability solid solutions in terms of the relational data model. On this slide we can see the scheme of formal relations. We can notice the main relationships like element, its relation of characterize a subgroup of elements, charge element, relation of characterizing element charges, coordination element, relation of characterizing charge coordination numbers, storage system relation for the characteristics of given system which was calculated, and etc. I would like to highlight one function for entering data into the system. In the process of creating an element, the possibility of adding general parameters to the element is taken into account, element param function. So for each element it's necessary to ensure the indicators are obtained from the database. Therefore, is the parameter p of some I elements from n is not presented in the system. The universal value pdf is chosen, otherwise it's necessary to enter the value p. Let's formally define params R products. Some function for prediction. In the prediction process, data analysis first taken place pred analysis function. For each system it's necessary to ensure that the indicators of each element are obtained from the database and analyze where it's possible to make a prediction. Therefore, if the parameter ai of some I element from an is not presented in the system, the universal value adef is chosen, otherwise it's necessary to enter the value ai. Let's formally define analysis products. During data analysis, it's also checked whether such a system with the same set of input data has already been calculated, pred-analysis data function. If it has been calculated, then we output the found data. Analysis and compression of data from the database, namely in tables, stored system and stored results, is carried out. So if the SD data of some DES element from SR is available in the system, we pass the SD value, otherwise as found. We formally define the analysis data product. Also, I would like to show some operators. For data processing, after setting the type of prediction algorithm, the prediction function was created. A certain set of fields must be passed to the function. Element ID is unique ID of certain element of the system. STRS ID identifier of the structure of the solution. Element ID LN ID of certain lengthened apps, calculation step, algorithm TP, type of algorithm. Formally, the prediction operator has the form. To display the data on the interface, the return result function was created. It's necessary to transfer certain set of fields to the function. stdr ID, unique ID code of data about the calculating system. Formally, the data display operator on the user interface. I would like also highlight the operator print. In order to visually easily show how an element was created and which elements were entered in this system, a function was created to print the table of print element elements. Actually, each element is formed from a certain set of fields. Element ID, code, name, count. Formally, the element print operator. Scientific and technical result. In this work, for the first time, a knowledge-based model was created for prediction the feasibility solid solutions, which, unlike the existing ones, takes into account the unique limit of substitutions of each lengthened, with help of set production rules, predicates, functions and operators, which allows to increase the accuracy calculation of the energy of mixing and to calculate the exact and not the general critical decomposition temperature of the corresponding lengthened. Thank you for your attention.